chemical weathering. What is chemical weathering? So chemical weathering, which involves chemical processes, oxidation, reduction, hydration, hydrolysis, acid base reaction. So likewise we have chemical processes. So this chemical processes which are taking place at the surfaces of the rock. So oxidation is nothing but O2 is getting. How is O2 is getting is nothing but at the surfaces. So a rock is made up of a particular mineral. So I can say this is an atom, element, mineral and rock. So this is a sequence. For example, say atom, hydrogen. So hydrogen as an atom, H2 as an element, mineral, different molecules. Say for example mineral FeS2 is an iron pyrite. Iron pyrite is a mineral. So rock, so there can be different two minerals may be present or a one mineral as a wholly forming rock. So we have rock, it is nothing but a chemical structure of maybe different sort of minerals. Now so this we have some as examples given as in chemical processes. This can react at the minerals present in the rocks and the bonds will be broken and it will be disintegrated into different minerals as solid particles. So it is an if we compare physical weathering and chemical weathering, so chemical weathering it is an very much important to a civil engineer. So because of this soil nature, so the solid particles which are produced from this chemical weathering have electrically charged nature. It is very important, very important phenomenon. So this solid particles which are produced by the chemical processes different. For example, I can give Fe2O3, it is hematite hydration processes, 3H2O added Fe2O3 dot 3H2O, it is limonite. So this hematite can be transformed into limonite, which is nothing but of different mineral. So like that all these particles which are produced from chemical weathering will have electrically charged nature. We will be seeing that later in detail. We are going into biological weathering. What is biological weathering? Biological weathering is nothing but any vegetation action or animal action or man-made activities which can produce soil. As soils are produced from rocks, that is the concept. So if it is produced by this vegetation action or man-made activities or animal activities, so during the migration of ant, soil can produce. It may lose the bond. So that we have already known that. So biological, it is a kind of a biological activity. So what is vegetation activity? Say for example, a seed is placed over an rock. When water coming into picture, so the seed will grow as a small plant, starting grow as a small plant, and it can break a rock when the root develops to reach the soil. So that is an kind of an biological weathering. So animal activity. So during the migration of any wildlife, it can produce rock, soil. So then man-made activities, so because of this our movement, then during the ploughing of the land, if soil got produced, so that is also coming under biological weathering. So that is nothing but biological weathering. It cannot, I don't want to explain more about it. So we have in detail about physical weathering and chemical weathering. So at the end, chemical weathering produce cohesive soil. Physical or biological weathering will produce cohesive soil. So this is an major part we are going to look into that. What is cohesive soil? It is a very important thing. So what is cohesive soil? So what I am holding as an cohesive soil. What is cohesion? So the thing you are seeing in my hand, it is not a single particle. It is not a single particle. It is a binding of small particles. So that binding is nothing but cohesion. It can be described as, so it is a particle to particle attraction of same nature is cohesion. So all these particles I have in my hand is in clay. So it has a cohesive nature which is produced by this chemical weathering as the product solid particles has electrically charged nature. So this electrically charged is nothing but cohesion. So particle to particle attraction of single particles is nothing but cohesion of same nature. If particle to particle attraction of different nature of any particles or any object is termed as adhesion. So this cohesion is nothing but this electrically charged nature. So if you look at the sand, sand particles can be seen through naked eye, which means sand particles are little bit very larger, which is from 75 micron to 4.75 mm range. Particle soils are nothing but sand because it is classified according to the particle sizes. So this individual particles cannot be it doesn't have any bonding nature between, but this cohesive soil has bonding nature because of the process which got produced is nothing but chemical weathering. So that is a thing you have to keep in mind. So this cohesionless soil is nothing but a sand or gravel or pebble or boulder like that. So this doesn't have any particle to particle attraction, but this cohesive soil has particle to particle attraction. So because we have to keep this cohesive as well as the cohesionless soils in your mind, so that will be flowing from unit 1 to unit 5. So this behavior are changing. So cohesionless soil has different behavior and approach differently, and this cohesive soil has different behavior and approach differently. So when I am holding this small lump of cohesive soil, I am trying to break this. So I am applying load and I am trying to break this, but it doesn't broken, which means a single particle, do you know the particle size of a clay particles? A clay particle has a maximum size of upper limit 2 micron. 1 micron is nothing but 10 to the power minus 3 meter, 10 to the power minus 3 mm. So we know a normal scale, say for example an 15 cm scale or 1 feet scale, the least count we can measure is 1 mm. As all of you know about 1 mm, if you make 1000 divisions in 1 mm, that small one division represents 1 micron. So you can imagine what is the size of 2 micron. So that 2 micron is in clay particles upper limit. So finer than 2 micron are nothing but clay. So all those things has. So this much volume of a soil a lump of soil has too many count of, say for example, infinite count of clay particles. So all these clay particles has cohesion in nature. So if you're trying to break this, if you're applying force, for example 0.1 kilonewton I am applying, so all this cohesion will playing major role against this applying force. It can give more forces. Say for example it is broken at 1 kilonewton, so 1 kilonewton is an resisting force given by all this individual accumulating all these particles as cumulative load. So that is the thing. So now cohesionless soil and cohesive soil. So as I have already described, so clay soil are having cohesive natures, so and which have an upper limit, so it can be equal to 2 micron and lesser than 2 micron are nothing but cohesive soil. So here cohesionless soils are greater than 2 micron in general, so I cannot put equal here. So cohesionless soil and cohesive soil, so if this cohesive soil, say for example sand which is greater than 75 micron, sand which are greater than 75 micron can be grinded lesser than 2 micron, say for example, so all the sand particles are grounded lesser than 2 micron, it can be a cohesive soil. It cannot be cohesive soil because this sand producing by the grinding process to lesser than 2 micron is an physical process. So all the soil produced by this physical processes leads to cohesionless soil only. If any rock or soil got produced by chemical processes will leads to cohesive in nature. So that is the thing you should keep in mind. So let me give a small example how this soil have that plus minus charges. So basic structural unit, say for example kyanite, illite, montmorillonite, bentonite, vermiculite, chloride. So I can give a lot more examples which are examples for clay minerals which are cohesive soil. So let me describe how these cohesive natures are coming. We have a silica SiO4. So silica at center, and so we have a tetrahedron. So SiO4. So 3 oxygen at the bottom are forming a base and 1 oxygen atom at the apex forming a tetrahedron. Tetrahedron is nothing but which have 4 phases, phase 1, phase 2 and phase 3 at back, at phase 4 at the base. So this is an tetrahedron. So silica will have a structure like this, and so there is and one more oxygen atom, and so likewise it is another SiO4 is attaching through 2 oxygen atoms. Likewise it is continuing and it will be forming a layer like this. We are representing this by S. And Al2O3, alumina, it have a nature of octahedron. How a octahedron will be? So this is an octahedron. If you look at this, phase 1, phase 2, phase 3, phase 4, 4 faces at the top about this base and 4 faces below about which this base. So it is likely being continuing like this. So likewise it will be continuing, and this forms a layer like this known as gypsite. So this silica and gypsite this is silica and gypsite. This is a single structural unit. It is a single structural unit, but this is not a single particle. It is not a single particle. It is a single structural unit forming by silica and gypsite. So and this is attaching through H bond. So bonds ionic bond, covalent bond, and van der Waals forces. H bond. So ionic bonds are like a K plus bond, so that potentially comparatively higher in force. Covalent bars are permanent dipole bonds. These are van der Waals force are fluctuating dipoles. So as I am ordering, it is in descending order. Higher bond, this bond is strong, comparatively lesser bond, and comparatively lesser bond. So here we have an hydrogen bond, permanent dipole bond. So it can combine another basic structural unit into contact. So now it is going about 70 to 140 layers to form single particle. So a single particle will be like this. So in scanning electron microscope, same in the short form, scanning electron microscope. So it is all the particles will be like that, but you cannot see it. You cannot see this as a particle. You can see this. So this flaky particle will have electrically charged minuses at the surfaces and plus at the top and bottom. This is a single particle. It is a single particle which have, say, this basic structural unit. This basic structural unit has 7.2 into 10 to the power minus 10 meter. So 7.2 angstrom. So this is multiplying with 140 times. That is nothing but thickness of this, size of this, a single particle. So this single particle will be lesser than 2 micron. Is a very important thing you should keep in mind always this. So this plus and minus, this plus minus will be playing like this. So minus will be attracted by plus and got neutralized, and this is minus and this is plus, and it will be going like this. So this is flocculent structure. It is a flocculent structure. So that is nothing but I have already explained. So this bonding is nothing but cohesion. As you can see, this is a very strong when it is dry state. So that is the bonding, and the respective structure is flocculent. We have another structure, dispersant structure. This clay sample, so this clay soil is very well when it is dry state. But when you add water into this clay soil and you can simply squeeze this clay sample. How? So that is what the headache with this soil. So a particle, when you add water, it is forming, this particle is an electrically charged. So water is taking place as a thin layer. Again you add water, again it will taking place. So a particle which has already has contacted will be coming like this. Because of this lubricant action by the water, again it is taking place. So initially which is like this, got slowly by the influence of water it is turning to this. So now it is minus at the surfaces and also minus at the surfaces, and this got repulsed. Previously it is attracted between each other called cohesion, and due to this water influences it is slowly turned as a lubricant, water as a lubricant, and this is minus and this is minus. So this minus minus will be repulsing each other and going outwards to each other. So this outward to each other, if you initially take an 100 ml of dry soil, if you add water, it will be slightly got increased. We are telling this as an swelling nature. So initially I have started with the topic nature of soils. So nature of soils can be broadly classified into cohesionless soil and cohesive soil. So cohesive soils have the nature of particle to particle attraction of same kind. Cohesionless soil, whereas your cohesionless soil doesn't have any that nature. So it will transfer all the loads as a foundation structure loads, it will transfer all the loads to the particle to particle interlocking. Whereas your cohesive soil at the dry state, it will transfer all the loads through particle attraction, which is nothing but cohesion it goes, but it loses its cohesive nature when water coming into picture. So this is makes an entire difference. So cohesive soils are headed to a civil engineer, which behaves different manner when water is acting, when water is in contact, and water is not in contact, which will behave both very strong and very weak. So that is an headache to a civil engineer. So that will be discussed in my following lectures. Before that, I am concluding my session with a small comparison of steel with soil, steel or concrete with the soil. In case of a steel and concrete, if you need an compressive strength of 20 FCK, 20 megapascal concrete, if you need, you can prepare by selecting the ingredients. Concrete, I mean aggregate proportion, sand proportion and cement proportion, you can produce as expected compressive strength given concrete. But in case of soil, it is entirely different. A soil which are produced from the millions of years, as I have already told, at less than 4.2 billion years, soil got produced from rock. Say it is lesser than 4.2 billion years, say it is a millions of years of soil. It is a natural product. You cannot create, you cannot produce soil. So what are the things you are seeing at the river, adjacent side, say for example river sand, it will take too much time to again produce a river sand. So that is why it is a limited source. We are restricting the theft of sands. So as I am coming to say, soil is a natural product, you cannot control the property. But steel or concrete as expected strength can be prepared, but soil you cannot prepare. Instead you have to adjust with the soil property. So that is why there are so many tests to understand the soil. So that is the thing. And second thing is, if you have a soil and concrete, it can be easily transported to any trucks, one place to another place, it can be easily transported. But whereas in soil, which is an construction material, construction material for this huge embankment, huge soil embankment, earthen embankment. So earthen embankment. So if you calculate this volume, it will be very tremendous to leading a flyover here. So it will be very tremendous in volume. So you are doing in this transportation kind of tremendous volume, it will consume too much fuels for this vehicle. So it will leading to uneconomical transportation and leads to higher expenses. So what I am coming to say. So you have to do proper calculations for this. So leading with efficient transportations. So then what we can see, so steel or concrete have a linear elastic nature. So linear elastic nature we have in case of steel or concrete, whereas your soil doesn't possess any linear elastic behaviors. So it doesn't just in particulated materials, it won't play this linear elastic nature. Then testing. In case of testing, so steel or concrete can be tested by compressive strength accordingly. But in case of a soil, once you are digging, you are collecting sample for a testing, once you test the soil, it got disturbed. The interlocking or a structure of an particular particulated soil has disturbed, you cannot test it properly. What I am coming to say is, as a concrete or a steel for a tensile strength or for a compressive strength, it can be tested properly in a laboratory. To test a soil in a laboratory, you have to collect sample from a field. Once at a field, you are trying to collect a sample, it got disturbed, which means it is thixotrophic nature. Once you are touching the soil, the structure got disturbed, and you cannot test it as an undisturbed sample. So if you applying compressive load and it is not, we are getting some compressive load at failure, it is not representing the field. So there are too many complications present in this soil. So now I am concluding that session. So with the help of this steel soil comparisons, so you can completely, I hope you can completely understand the nature of soil, which are mainly played by cohesionless and cohesive in nature, as I have explained before. Thank you very much.